Problem 3. Find the equation of the line tangent to xy squared plus 5y plus 12 equal to 0 at the point -2, 4. So clearly this type of equation indicates we have to use implicit differentiation, right? When you've got x's and y's jumbled up together and they want you to find a tangent line, they want you to find the slope of the tangent line, meaning we have to find the derivative. And when their x's and y's mixed up together, we have to use implicit differentiation to find the derivative. So let's go ahead and find the derivative. So we're going to take the derivative of both sides. So we're going to use the product rule here. The derivative of x is 1 times, leave y squared alone, plus x times the derivative of y squared is 2y times y prime. Right? The derivative of some stuff squared is 2 times your stuff times the derivative of your stuff. That's the derivative of xy squared, plus the derivative of 5y is 5 times y prime. Right? So the derivative of 5 times y, and the derivative of y is just y prime. The derivative of 12 is 0. The derivative of 0 is 0. Okay, now normally we would then solve for y prime. But since we already have a point to plug in, we can just plug in the point right now. So we can just say, all right, I'm going to plug in -2 for x and 4 for y. And you get 1 times 4 squared plus -2 times 2 times 4 times y prime plus 5 times y prime equals 0. So let's see, 16 minus 4 times 4 is minus 16y prime plus 5y prime equal to 0. So 16, let's see, -16 plus 5 is -11y prime equals 0. 16 equals 11y prime, so 16 divided by 11 equals y prime. And that is your slope at this point. So the point is -2, 4, and the slope at that point is 16 over 11. So then we can find the equation of the tangent line by saying y minus the y coordinate equals the slope times x minus the x coordinate. So y minus 4 equals 16/11 times x minus -2. Usually they want you to isolate y, so we can say y minus 4 equals, if I distribute the 16/11s, I get 16/11 x, and then 16/11 times +2 is going to be 32/11. I'm going to add 4 to both sides, so y equals 16/11 x plus 32/11, and 4 I'm going to write as 44/11, and then finally y equals 16/11 x plus 32 plus 44 is 76/11. We also could have actually solved for the derivative here, so we could have, if we wanted to, right, instead of plugging in points right here for x and y, we could have actually gone ahead and said, okay, I'm going to solve for y prime, so keeping these two things on the same side and factoring out the y prime, you get y prime times 2xy plus 5 equals, you bring this over, -y squared, and then y prime equals -y squared over 2xy plus 5. And then if you plug in, you get y prime equal to, let's see, plugging in 4 for y, so -4 squared divided by 2 times -2 times 4 plus 5. -4 squared, be careful, the 4 is getting squared before the negative happens, so that's going to be a -16 divided by a -4 times 4 is -16 plus 5 is -11. Oh, that's 16/11. So you can do it this way, but it feels like a little more work. So if you're finding the equation of a tangent line using implicit, if they're giving you a point to plug in, you don't have to actually solve for y prime. You can just go ahead and plug in that point as soon as you've taken the derivative of both sides without doing any other simplification.